It's all official.
Okay. I have a question on 69, but I can ask you after class, or I'll ask the
I'll go
tutor.
for it. I'm still missing 12, so I just wanted to.
Okay. Well, A is easy, B is easy, D
What
is
problem
just
are we talking about?
69 on 7.1. C, you just kind of walked me through how to do. But I don't understand how to do it in a non-normal, because it's a wedge-shaped distribution.
All right, here's the problem. No. Uh, the distribution of individual values is wedge-shaped. Definitely. Definitely. That's what they say. Why would I care? Because what is it we're talking about? What does this symbol here mean? What does this symbol mean?
The X of our survey.
What does the X of our survey mean? I don't know. What is this?
In words, X bar is the 1,000 residents of that country that we surveyed.
No, X bar is not a group. X bar is a number. What would that number represent? What does X bar, the symbol, represent? So you've got
the average salary
for who?
per year of the surveyed 1,000 residents of.
All right. So the symbol X bar is always a sample mean. The symbol X bar is always a sample mean. You must know this. You must commit that to memory. Now, did they take a sample?
Yes, they did.
Yes. Are they asking about the sample mean?
Yes.
Yes. Therefore, and how big is the sample?
1,000.
1,000, and that's bigger than some certain special number. There's a certain number that my sample size is bigger than, and then I know something neat happens.
Oh, when it's bigger than 35?
30.
30. It's
Yes?
supposed to be a normal distribution.
No, it is a normal distribution. Normal enough. So then your problem is gone, right? It's not wedge-shaped because I'm not looking at the individuals. I'm looking at the graph of all means. And that I know is normal.
Okay. So X bar is approximately N.
Yes.
And then I figure out.
Here, and you put the new standard deviation in there. And that, of course, is what you're going to use to get a z-score and all that kind of stuff for part E.
Okay, thank you.
Sure.
Really quickly, I just wanted to check for 77E as we went over and doing it backwards. I got an answer that seems a little bit low.
Where are we at again? Is this chapter
6.2? Okay. I'm just going over my homework, like my old ones. 6.2, the 77E, the 70% question.
Yeah.
I got 1.44, which seemed kind of low, but I wasn't sure.
What z-score did you get?
Negative 0.52. Because I took 0.3 as the area underneath, because 0.7 would be the area above.
Okay.
And then 0.52 was negative 0.52 is the z-score. So then it was negative 0.52 times, oh, I wrote that wrong. Never mind, we're good. Carry on.
You say it sounded good.
Wait, for that, I got the z-score as negative 1.3333.
I don't know. Let's find out. So we're looking up.
Z equals 1 minus 3 over 1.5.
Stumped. No.
Okay.
All right.
I have to go back in my book.
Are we talking about part E? Or no, you're talking about part C. Right, Billy?
I was just hopping on her question because I haven't corrected that homework yet as well.
For questions about part E. And I think you're talking about part C, because that's where they got the 1 hour.
Yeah.
Okay, so you're fine. Sounded like you got the z-squared formula set up correctly. That's fine.
Oh, E I had a question. E I highlighted, like I needed to ask you about it.
Okay.
I got 1.5 times 0.53 equals x minus 3 over 1.5.
Whoa. I don't know what that
Oh,
is.
sorry, I was canceling things out. So 0.53 equals x minus 3 over 1.5.
Stop. So, all right. Again, I think a lot of your issues would be alleviated. I thought you were making a cheat sheet for yourself to use on homework, identifying the symbols and what they mean. Nothing wrong with that at all, to have that sitting next to you as you do homework. Nothing. In fact, that's a beautiful idea. I thought another good thing is to have just the formulas there for yourself. You've got that one, and then there's this one. So this is already solved for x, so you don't have to solve for x every time. That's one thing. Now let me ask you guys this, because part E has got a little weird English problem, right? Even for those of us who's, I always say a joke that my second language is English because my first language is math. But for those of us who grew up in English, it's still a hard language. So here's a problem. How do you draw this correctly? Holy shit, how do I, as I draw a complete shit normal curve? It's all right, Jeff. It doesn't matter. Very few people seem to be able to identify where this is. So let me ask you this real quick. I tried this earlier. The mean here is 3. Let's say that I know there's, how did I say this earlier? Yeah, I know there's 0.80 there. Let's just say I know that. Are you guys with me?
Mm-hmm.
All right. Does this mean, what does this mean? Like if let me see. These 80%, did they play for at most 4 hours or at least 4 hours? If I'm a child in this
At most 4 hours.
at most 4 hours. So this is 70% at least. So if I draw it like this, I am wrong, because that's at most.
You shade the other side.
So the 0.7 should be on the other side. So that's a big mistake people are making with 77E. And again, it's just the English words. The at least and the at most are freaky. They just are. They don't work well with math because they're weird in the first place. I don't know if that helps anybody out. So that's wrong. You don't want to draw it like that. So where would at least 70%? How would I draw that? I would draw it down here. This is 0.70. So then the z-square I'm looking for will be negative. Okay. Maybe. All right. I feel like you guys are all like, man, I really hated this guy before. I didn't realize how much my hatred could grow. I don't know if that's true or not, but if it is, oh well. Ask questions. It's amazing. Anything else, guys, before we get back into where we left off? Everybody understand when the quiz is due. There's a quiz active right now. When is it due?
Midnight tonight.
Midnight tonight. Right? Or else turn into a pumpkin. Ah, ha, ha, ha. All right. Anyway. So just do the quiz. Don't forget about it. It's in there. Do it. I think about 13 of you. Lucky number 13 have done it. Let me real quick make sure nobody's in there right now doing it. You kids, you. All right, let's see. Do. No, okay, good. Let's keep it like that. All right, guys. Anything else? Any other questions? Can I check an answer I got with you? Okay. Real quick, what you got? What section?
It's section 8.1.
8.1, okay. Number 9? Okay, you're very quiet. Let's see.
7.94, 8.46.
Yeah, good.
And then I have to write, also we are 90% confident, like that whole thing, right? Or,
Yeah, like I said, if the book doesn't technically ask for it, you technically don't have to write it, but you might as well write it to get some practice.
okay. All right, cool, thank you.
Sure. Samantha?
I don't know if you can explain me really quick the part 4 of the quiz.
I'm sorry, the which one?
The number 4 of the quiz.
Number
The
4.
quiz number 4.
All right, hold on. Let me see what kind of problem. Let me see what I can say about that.
The B part.
Number 4. There is no number 4. There's a number 1 and there's a number 2.
No, of the practice quiz.
Oh, practice quiz. Okay. All right, hold on. All right, hold on. Here we go. Here we go. Where is it? Where is it? Where is it? There it is. All right, practice quiz. Oh, no. Oh, wait. You're looking too far ahead, Jeff. Okay, sorry. Which one?
The number 4, the B part.
Oh, yeah, number 4. Okay. So this here.
No,
For
the B.
part for this one? Yeah.
Uh-huh.
Sure. What about?
I don't understand where it come the 88, I think,
88.
on the answer.
Oh, okay. For which part?
For the number 2.
Okay, number 2. I don't know. All right. I don't know what 88 is. I don't know. But if we do this, what did you? All right. So what's the mean that you're using? You got to make a z-score, right? So I could draw this little picture. I got 35 stuff in the middle, and I got 34, and I got 35. Blah blah blah, blah blah blah. So I got to make a z-score for each of these, right? Are you with me so far? I got to make these into a z-score. Is that cool?
Okay.
What mean are you using? So here's the formula, right? Kind of give the game away here a little bit. What's mu? What are you putting here? I mean, how did you do? Did you do number 1?
I do.
You did? Okay. How did you make the z-score? You did 37,000 minus what divided by what? Right? No? Yes? Maybe? Is that how you did it? How did you do number 1?
A would be, we can use the z-score chart to find probabilities for sample means in this problem because it follows a normal distribution.
Why?
Because the sample is more than 30.
There it is. Okay. Now we're on part B. So the mean is 35,397, right? That's what you should put here. But down here, am I going to use this number for the standard deviation? Is that the right number to use?
No.
Yeah, how do I change it so I can use it for part B?
You divide for the number of the students.
Yes, so the 128. So whatever this number is, it's what goes on the bottom because that's the formula. That's the formula right there, right? So I'm going to use the exact same formula and make a z-score out of this number and a z-score out of this number.
Oh.
So I'm guessing I got 0.88 or something for one of them. I can't remember.
Yeah, I think I was doing both and the same formula, so that I think that's the problem.
It can't work because neither one of these numbers is the mean, and the formula needs you to put the mean there.
Yeah, I know what's the problem.
No, don't feel bad. I get that all the time. I get people to put them in, and I don't blame you. You're like, dear God, let this problem be over. If I just put them both in there, then I'll make it quick. But then you're going to be wrong because you have to put the mean there. So you can only change one thing at a time into a z-score.
Oh, okay, perfect. Thank you.
Right, this is good shit. It's good stuff. All right, everybody else okay? You guys, are you the state of being that passes for okay nowadays? Is that a better way? I call it, I used to call it 2020 okay, and it's basically 2021 okay at the same time, which means everything sucks, but it's relatively fun. All right, so we left off. If there's no other questions, let me pull this up. Oh, let's see. Can you please go back to that screen? What do you mean? The one that had my notes that have now disappeared because I went away from it? This here with, yeah, my notes are gone because that's what happens when I close it. Sorry. But I think that, is that the one we were talking about? I can't remember. Yeah, I'm sorry. You got to let me know quickly. You got to say, can you keep that up for a minute or something? Oh, it was the practice. Yeah, it was the practice. Whatever it was, what I wrote down is gone because that's how the annotations work with Zoom. Right, let me open this sheet up. This is the sheet we were working on yesterday. It's called, I think it's called Hypothesis Steps or something like that under Chapter 9, Unit 9. Here, let me throw this up here and see if you guys remember this beautiful thing here? Talking about something that I think all of you were hoping I would get to is the northern Minnesota Coyotes. I know you all came to this class like, please tell me we're going to analyze the northern Minnesota Coyote. And we got there. We did it. So let's remember what we've done so far. So the first thing we did was, the first thing you pretty much always do is you find the claim. What is somebody wanting to test? What is somebody saying is true? They don't always use the word claim. What kind of word do I use here? A researcher believes. Okay, so the next part of that sentence is going to be the claim. So I write that down right there in Mathish. Cool? Because his claim is that they live longer in captivity. They normally live 10.15 years, so his claim translates to their average is more than 10.15. Is everybody? So the very first thing you want to find is what's the claim. That's what gets everything started. Because if there is no claim, why? I have nothing to test. Okay. Now, if you weren't here yesterday, I'm really sorry. You might want to rewatch that video. So we talked about the two old guys in the Starbucks. Standard statistical terminology, right? And then of course we got the hos and the ha's, right? The null hypothesis, if you want to be technical, and the alternate hypothesis, affectionately known as the hos and the ha's. Okay, let me stop for a minute. So you want to start with, what are you talking about? That's really, what's the claim? What are you talking about? What's the claim? The claim is what we want to check. So that's what gets us started. Now, why did we put this statement next to the ha? Why did we put the claim next to the ha? So you remember? We can just read, to be honest. What's got to be true about the statement that's next to the ho?
Equal to?
Has to have an equal to sign. Now, please, dear God, I'm going to say this, probably we had to choose a way to kind of set this up. So this is the way that was chosen. It could have been a few different ways. So we said, we're always going to put the statement with an equal sign next to the null hypothesis. That's what the null hypothesis is going to be, is the statement with an equal sign. And let me say this. Stay with me. If somebody claimed that the average age of Grossmont students is 27, can you show evidence for that using a sample? Can I take a sample and show evidence that the mean equals 27? What if you take a sample and the sample mean is 27? Is that evidence that the actual overall mean is 27?
No.
Does that make sense? Does that not make any sense to somebody? I want this question to make sense. That's the right answer is no. So if I get a sample and the mean is 27, what could the real population mean be? Any frickin' thing, right? Does the sample mean equal the real mean? I would put money on no. Are you guys, does that make sense? I got very few of you that I can see your faces, so I'm always kind of like looking to you guys. See, you don't. All right, sorry. I don't want to put more pressure on you because you might turn the camera off again, and then it's me talking to blank screens, and I go crazy. All right. So the statement that has an equal sign, I can never show evidence for it. But can I show evidence against something equaling something? Yeah, if somebody's like, I think the average age in this room is 20. And then I walk around and take a sample of 70 people and my average age is 73. Does that feel, now it's not good enough to say this, but does that feel like it's probably evidence that that first person was wrong, drastically wrong? No, do you guys know? Part of me is happy if you guys are like, well, what's the standard deviation, Jeff? Because you're right, you don't know. But freaking when the guess is 20 and your sample average is 73, I'm pretty sure that's good evidence that that's bullshit, right? So listen. A sample can vary from the real mean. That's why I can't use a sample to prove the mean equals something. But if the sample is far away from somebody's claim about the mean, that I could use a sample to show evidence that is greater or less than or different from. Yes, maybe? No? So the way we set this up is that the statement that goes in the ha is always the one that we can show evidence for. Can I show evidence the mean is more than this? Yes. I could take a sample, calculate the mean, and show that it is really far away. It's unusually high. Does that make sense? Sorry. Thinking about a past episode of my life. Anyway, sir. Are you guys striking that last statement? Sorry. Are you guys with me at all? So I could use a sample to show if the sample falls unusually far away from what the supposed middle is, that's evidence that's not really the right middle. I really want that to just make sense by itself. So that's why we do what we do here. What are we going to do in this process? does this make sense? All right. I love you guys. Oh my God, I have no idea. All right, sorry. I keep messing with my camera. Does what I just said make sense? That if I get a sample that is so far away from what the real mean should be, that's evidence that this is not the real mean, right? So like I said, if I walk into a room and the average is supposed to be 20 years old, and I take a sample and get an average of 73, a random sample, let's say it's 70 people I took an average of, and my average is 73. Wouldn't you say that is unusually high if the real average is 20? So what's more likely? I just happened to pick a bunch of old people, or the actual average is higher? The actual average is higher. That's what's more likely. Okay, I like it. This will not lead to proof. This will lead to evidence. And that's the best that humans can do, is evidence, right? All right, okay. So all we're doing, this very first piece, I call this the what are you talking about piece. What are you talking about? What's the claim? What's the old guys in the Starbucks think? Right? And now, why did we say it was one tail?
Because it's only greater than?
Yeah, the only way I could show evidence, I'm sorry, let me erase this so it doesn't look like there's an equal sign there. I was underlining that. That's not good. All right. The only way I can show evidence for the ha is to find a sample in this one direction. Not the band. So that's why it's a one-tailed test. There's only one way to go to show evidence that it's greater. Does that make sense? If I find a sample down there, does that do anything for me? No, it doesn't show shit. It can only be up here. That's why it's a one-tailed test. And again, that's why the t-score chart is set up 1 and 2-tailed. You guys, does that kind of complete the loop there? When you first got it, you're like, what the shit's all this? What is this 2 rows business? Well, now we know there's 1-tailed tests and there's 2-tailed tests. And we'll do a 2-tailed test immediately after this one. Okay. First step, what are you talking about? What's the claim? Second step, what can you use to talk about the claim? Can you use t-scores or z-scores? Well, Billy, you okay? All right, I'm getting sick watching that. I don't know what happened. So part B is a very familiar step. There we go. Part B is the step, is it normal enough, right? And then, so is it normal enough? Yes. Is everybody cool with that? What if this was a percentage problem? Who remembers how to show it's normal enough? Because we're going to do percentage hypothesis tests. Anybody remember what the check is?
E? Was it the NP and the NQ?
NP and NQ have to be
5?
5. Good. Okay, so we're going to see hypothesis tests for percentages. And how do I show percentage stuff is normal? NP and NQ have to be at least 5. Does that sound familiar? Same idea behind the step, just a different way to tell if it's normal or not. Okay. So why did I cross out t-scores here? So we can use z-scores. Why did I cross out t-scores?
Because we know the population standard deviation.
Yes, the reason t-scores were invented was for when I don't know the population standard. I got to cover my ass for only knowing S. In this case, I know sigma. I don't know. I just want to, I don't know, sorry. Wingardium Leviosa. No, didn't work. Okay. It's Leviosa. All right, that's all right. So first step, what the hell are we talking about? Second step, what can we use to talk about it? Now listen. Remember what I was saying? The sample, not only does the sample have to be different, it's got to be different enough. It's got to get into unusual territory, right? I really want that to make sense. If somebody makes a claim and we go do something that is unusual, if that claim is true, then it's more likely that the claim is false. Let me say that again. If somebody makes a claim and we do something that would be really unusual, if that claim was true, it's more likely the claim is false. The more you understand that statement I just made, the more you understand these things, these hypothesis tests. Do you have to understand what I just said to be able to do these problems? No. So step C is defining how far away is far enough away. I like that phrasing. Our sample has got to be far enough away to be evidence that it's different, that the real mean is different. Because what does the sample mean do? It's going to be different already. Of course, the sample mean is going to be different. So it's got to not just be different, it's got to be different enough. So this is just defining, and I say it right here, how far away, I should have said the whole thing, how far away is far enough away, right? Where does unusual start? It used to always be 2 steps, right? Remember the good old days? Sorry. But now it depends. Remember the thing about the nuclear power plant? It depends on the situation. So they're going to have to tell me, how do they tell me where unusual starts? By telling me this bad boy. Let me say that in chat. If somebody makes a claim and we do something. Oh, let me say this one more time. All right. So this is what I was saying earlier. If somebody makes a claim and we do something, we achieve something that would be unusual if that claim was true, then it's more likely the claim is false. So if somebody said, man, you will never see 2 turtles in this creek. And we get up the next morning and we see 2 turtles. So wouldn't it be, if his claim is true, wouldn't it be more than just unusual to see 2 turtles? If his claim is true, you will never see 2 turtles. Okay, then how unusual would it be to see 2 turtles if that claim is true? Wouldn't it be like crazy unusual, like impossibly unusual? And then we see 2 turtles. So what does that say about his claim? Anybody?
It's false
false.
or close to
Bullshit.
impossible.
It's bullshit. It's false. We can reject it. We can reject his claim then. Does that make sense? Now what about this? Let me soften that a bit. What if somebody said, man, you hardly ever would catch more than 2 turtles in this creek, right? And the next 5 days, every morning I see 5 turtles in the creek. If his claim is correct, you hardly would ever see more than 2 turtles in that creek. And the next 5 days we see 5 turtles in the creek, right? Would that be really unusual if his claim is true? Yes. Do you guys agree with me? I don't know why I'm using turtles. I'm sorry if that's not helping.
Yeah, because we did something that proved the claim is false.
We did something that would be really unusual to have been able to do if the claim was true. So what's more likely? The claim is false. Now look at this. Remember, alpha is the area in the tail? So how likely, if the 10.15 is the real mean, how likely would it be to find a sample mean here? You know exactly what that number is. Can somebody tell me? Say again.
1%.
1% chance. Is that cool? Because there's 1% in this tail. So of course there would be a one. Would you say that would be an unusual, in fact, a highly unusual occurrence?
Yes.
Okay. So if this is correct, that would be really unusual to find a sample there. So if we do find a sample there, what does that say about anybody that thinks that it equals 10.15?
And if they're wrong,
That they're wrong. So if we, and which one of these thinks it could equal 10.15?
that one, the first one.
That one. Yeah, the first one. So if we make it into this area right there, if we make it in there, that is evidence that we can reject the null hypothesis. Because the null is the guy who thinks it's down here somewhere, isn't he? He's the one that thinks it equals this, so it should be somewhere close to that. And if we get up here, that's evidence the null is wrong. That's evidence the alternate is right. Are you guys at all with me? I know as a student, it's frustrating because you want to know exactly what formulas, what numbers, what do I do with the numbers, what do they mean? I understand. But the more you understand just the basic concept behind this shit, and then the formulas kind of come in when they have to. Far enough away is a z-score. Does that make sense at this point in this semester? How do I measure distance in statistics? Z-scores. So if a part of my concept is it's got to be far enough away, then I should expect to have to calculate z-scores. That's how I measure distance. All right, maybe. Did you guys take Tylenol before today's class? That probably would have been a good idea. All right.
Are we always given the rejection region, or is that something that we would have to calculate down the line too?
Well, see this 2.326?
Yes.
How did we get that?
Well, that's from the z-score based off of the tail being 0.01.
So that's what we have to be given. Now we'll say this. Does everybody understand our question? What do I have to be given? I have to be given alpha. If they don't give you alpha, wait a minute, Jeff, didn't you just say they had to give me? If they don't, you assume it's 0.05 because that's the most often used one. So I think the book even says, it's somewhere in there, a couple times it says, assume it's 0.05. So if you don't see an alpha anywhere, and let me, oh, you guys, oh man, you guys, I'm sorry, you guys love this section, I know, but here comes another terminology. Here comes another, did I put it up here? Did I put it up here? No, because I'm a dork. What's the other name for this? Are you ready? I might have said this before. Level of significance. So let me ask you this. If somebody did something that had a 1% chance of happening, would that be significant? Wouldn't you say that's a significant achievement? If somebody did, no, it's a 1% chance a human can jump that. Holy shit, he jumped that high. That's significant. What if somebody else came along and did something that had a 0.5% chance of happening? Would you say that's a higher level of significance? So the first guy did something that had a 1% chance. Somebody else comes along and does something that has a 0.5% chance. Would you say, come on, I love you guys so much. Listen, why would the 1% thing be a significant achievement if somebody did it? You all agree with me on that. Why would it be significant? Why would it be amazing?
Because 99 out of 100 times it wouldn't be that.
Yeah, because, yeah, exactly. I mean, it's a low probability of happening, correct? So if somebody can do something that has a very low chance of happening, that's significant. Damn, Billy, you're gonna make me, you're gonna, oh my gosh, I can't watch. All right.
All right, it's a new way to use my camera. I can switch it off.
All right. So if somebody else does something that has a 0.5% chance of happening, would you say that's more or less significant?
Less.
Oh man, the probability is smaller, which means it would be more significant. Does that not make sense? What if
Yeah,
something
makes sense.
had a 5% chance of happening? That's still pretty freaky, right? Right? 5% chance. But then what if somebody else came along and did something that had a 2% chance of happening? Is that more or less freaky?
More.
More freaky. So if somebody did 1%,
Oh.
that's significant, that's freaky. 0.5%, holy shit, that's even freakier, right? Okay, so I'm just trying to explain to you why we call it the level of significance. Because if I change alpha, it changes how significant a sample has to be to show evidence. I want it to make sense why we use the words we use. Sometimes there's a reason, and sometimes it's just because math people got drunk and kicked a word out of them at random. All right. Oh, where am I? Okay, so I have written so much on this thing. It's insane. Let me take some of this shit away. All right, so what I got to do, we have now set up the benchmark for showing evidence that the null is wrong. Okay. So if I find, and remember, the little star just means it comes from a sample. Sort of like p hat, x bar, z star, they all come from samples. Is that cool? Okay. So if the z-score I get from my sample is more than this, then I can reject the dude who thought it should show up in here. So if I do get into the rejection region, I can reject the null, support the alternate. Like we said earlier, it looks like that one dude's wrong, which means it looks like that other dude's right. Okay. So these are not two statements. This is one. This is one situation. If I say that guy's wrong and that guy thinks the opposite, well, then he must be right. Okay, I love you guys. All right. So now listen. What are you talking about? What can you use to talk about it? Where does evidence start? Right? How far away is far away enough? And then this step, of course, now that we know how far away is far away enough, let's freaking find out if our sample, how far did it get? So can somebody tell me can somebody, you guys are able to look at this? What's my sample mean? What's my sample mean?
12.45.
Good. What's my sample size?
128,
I think that was
was it?
41.
earlier.
Oh,
Yeah,
oops.
that's all right. Don't worry. 41. What's my sigma?
4.27.
4.27. And before I make a z-score, what do I have to do? You know, didn't we take a sample?
Turn it into a sample.
No, careful. No, turn it into a standard deviation for groups,
Oh,
individuals. Because later we're going to see an S, and we're going to have to divide it by square root of n also. Because S is sample for individuals, standard deviation, and this would be sample standard deviation for groups. That's coming up later. So before we make a z-score, we got to do this, and this should feel roughly familiar, right? Having to do this step. What was it? We just said 41, Jeff. It's right there. Whatever the hell that is. I think it's about 0.6. I have no idea. 666. I don't know. What is it? Well, 0.68. Oh, it is 666. All right. Well, 667 to be honest. So it's right next to hell. Right. It's the next address over. Okay. The actual number of the beast, by the way, is 616. It's a mistranslation. If you didn't know. Anyway, sorry. So now I just have to find. There's so many steps here. I understand. Do not forget what are the two most important steps? How far away does my sample have to get? How far away did my sample get? Yeah. Right? So now I'm going to calculate what I call Z star. It's the same formula as always. I just put a star on it just to differentiate it because this is another Z score, right? Just want to differentiate it. So it's going to be my data point. Now, what are we assuming the actual mean is?
10 point something. I don't know what it was.
Yeah, 10.15. We always assume, we're like assuming this is the real mean. Let's see if we do something that's really weird. So this will always be minus the number from the claim. What are you turned on over there, dude? All right, come here. Okay. Divided by the new standard deviation. So again, just remind you guys, step C was, how far does my sample have to get to show evidence? And then the next step, of course, is how far did my sample freaking get? I don't know. 2.3 divided by 2/3, so 3/2. 3/2, 6.97, 3.45. Is that right?
3.4482, right? 83.
I'm sorry. I got close. All right. So round it up. Feels pretty good. It's in my head. I did it all in my head.
It's better than I can do.
Okay. Thank you. Like, come on, Matt boy. All right. Just looking at that, is that pretty far away? 3.45. Is that an unusual value for a z-score? Yeah.
Yes.
It's unusual given our definition. Did I make it far enough away? Let me change my color here. Plot it. Where would this be? Where would this go on the picture? Did we make it in here?
Yes.
Yes, because we're more than 2326. We're way the hell up there. Did we just do something that should have been next to impossible to do if this was the real mean? Yes, it should have been a 1% chance. In fact, we made it even deeper in there. It's even less chance. So right there, what can we say? Which person do you think that shows is wrong? Which person?
The
hoe, exactly. Say it loud and proud. So we can reject hoe, support By the way, I don't know if you guys noticed that I cuss sometimes, and I say things like "ho" and stuff. I used to say to people, if I offend you, then just wait a minute. I'll probably do it again. This is why I love teaching college. So, okay. All right. How do we feel so far? It feels like a ton, doesn't it? Because this is the very first hypothesis test we're doing. I've got to talk like an insane amount on each step. So it feels like, is every problem going to take me a day and a half to do, Jeff? Maybe. No, it shouldn't. It shouldn't. So you're going to love this. You know what the last step is, even if you didn't read ahead.
Wait, what is the p-value?
All right, we're going to go back to that. I wanted to get all the way through this just to show you, you don't need it. And then I'm going to go back and tell you what the p-value is. But we already know the answer to this, don't we? Didn't we already write down the basic answer to this? Well, now I want to bring in more details. Plus, now think about this. If you're a statistician and somebody comes to you to hire you and they have a claim that they want you to figure out, when you come back to them, don't they want to know, well, how'd my claim do? Did my claim work or not, right? Do you guys understand what I'm saying? So I'm not going to come back to them and say, well, this and that. Well, no, my claim. Was my claim right or wrong? Don't they want to hear that? So your conclusion has to be about the claim. Which one was the claim? The ho or the ha? The ha was the claim, right? You see that? That's where we put it. So the ha was the claim. So how am I going to word my conclusion? I'm going to word it using this language because that's what we did with the ha, isn't it? We supported the ha because we rejected the ho. So watch this. Oh, you're going to love this. You're going to love this. Okay. We have found, I've got to do something better here. Sufficient, oh, Jeebus, evidence, Jiminy, whatever, to support the claim that, oh, get ready, kids. Listen to what I'm about to say. Plagiarize. We have found sufficient evidence to support the claim that the northern Minnesota coyote lives longer in captivity if they're given more room to roam. Good Lord. Do you understand what I'm saying? In general, should you plagiarize? No. Why is this? This isn't really plagiarization, is it? If that's the right way to say that. No, it isn't, because we're just talking about the claim, and that's what the claim was. We have found sufficient evidence to support the claim that the northern Minnesota coyote lives longer, livers in captivity if given more room. What is this? What should this say to a zoo or something that has, or a sanctuary that has northern Minnesota coyotes in there? What should they analyze based on this study we've done?
They should give their coyotes more room to
Yeah, they should say, how much room do we currently give them, and is that, should we increase it? Because there's a study that says they live longer if we give them more room, right?
Yes, sir.
And we just did that study because we kick ass and we use just made up numbers. I'm really sorry to tell you. I think I looked up the general lifespan, but there is no researcher that I know of. Anyway, sorry. All right, so let's immediately do another example and then we'll take a break because these kind of can get to you. Let me show you where this other example is. Is anybody still copying stuff down here? This is the sheet you want to have sitting next to you when you go to do section 9.5 homework. 9.5 is the one that has all 5 steps that you need to do. They're going to reference some stupid worksheet of theirs in the back of their book, and you're going to say, screw you. I want you to say that. I want you to look at your book and say, screw you. And then you use this, because this is for the people that aren't just using the calculator. All right, so let me go.
So we don't need the p-value to solve this problem?
Yeah, you don't, but I'm glad you said that. Billy was trying to remind me and now you did. Okay, thank you. Thank you both. So real quick, we got the answer, didn't we? We got the answer. In real life, nobody will ever give you an alpha. The alpha is something that each person reading the statistical analysis comes with. The alpha is like what it will take to prove it to me. I don't know if this makes any sense. So somebody could come along and say 0.05 would be fine. And then I'm like, I need 0.01, buddy. 0.05 is too likely. It's got to be 0.01. And then this person over there is like, it's got to be 0.005. And I'm like, you're insane. All right. I'm sorry. It's not helping. You're never going to be given an alpha in the real world if you're looking at a statistical analysis. They're going to give you p-values, and you can figure out for yourself if that's small enough or not. So watch this. Does this make sense? There's a 1% chance something shows up in here, but didn't we make it even further in? Do you guys know what I mean by that? There's a 1% chance something makes it in this general area, but didn't we make it like really far in that area? Therefore, hold on, we're getting there, Billy. Therefore, the probability that a sample would show up where we found it is going to be even smaller than 1%. So the smaller that probability is, and that's what a p-value is. It's just the probability that we got a sample where we did. So that's the technical definition. The p-value is the probability that you would get a sample as far away as you did. That's all it is. What's a better way, a more practical definition, is it's the area in the tail of our z-star. Where is alpha in this picture? This poor picture that I've drawn on so many damn times. Where is alpha? It's this whole area here, right? It's this whole area right there. With me? And when you say that's the tail, isn't that a tail? Okay, so alpha is the area in the tail of this z-score. The p-value is the area in the tail of our z-score. What was our z-score? 3.45, right? Can somebody look that up and figure out? So what I really want, let me draw this better over here. What I really want you to do is to find the area in the tail of our z-score, 3.45. Can you look that up on the z-score chart?
Could you just repeat your eloquent, I'm just taking notes. A p-value is the probability that.
All right, let me come back to what I was saying. The p-value is the probability that, well, from the very beginning, so the p-value is the probability that we would get a sample as far away as we did. That's what a p-value is.
Thank you.
Sure. So it's more specific, isn't it? So the 1% is sort of like that whole area. If you get it anywhere out here, it's freaky. Well, we got in there. We totally did, but it's kind of like pretty far in there, right? 3.45. Holy shit. So exactly how unlikely would that be? Has anyone found out yet? What is the area?
It says
Wait.
0.9997
Be careful. Where's that?
to the left.
Yeah.
So
Oh,
1
to the
minus
right.
0.9997.
It's
We skip 0.003.
0003. So what you guys got?
Mm-hmm.
Is that small?
Mm-hmm.
Hell yeah. That is effective. This is not quite right, what I'm about to say. It's kind of a weird thing to hear somebody say, right? That is effectively sort of a probability that the mean really is around 10.15. It isn't really that. It's more complicated than that. But that's not too far off from an interpretation of it. The p-value is so misunderstood. But basically, the smaller the p-value is, the more significant the evidence you found. There is more to the story, but not that much, to be honest. But that's good enough to get us through stats 1.
Okay.
I don't know how you guys are. Now, again, how many hypothesis tests have we done? We've done 1, right? So on one hand, you're like, oh my God, this is but at the same time, we've done 1. So if you feel uncomfortable right now, good. You're supposed to. Shit, we've only done 1 of these freaking problems. Are you kidding me? All right, so let's do another one. Let me show you where this is going to be in Canvas. No, did I?
I have a question.
Yeah.
Is the claim always going to be the alternate?
No.
Okay.
So real quick, if the statement has an equal sign in it, where does it have to go? Do you remember?
To the null.
To the null. So if our claim had an equal sign in it, wouldn't it go?
Yeah.
That's the key. Good.
Okay.
So the one we just did, it just happened to be the ha because it was greater than. There was no equal to in it. So that's why I want to immediately follow it up with this one. Here we go. Now it's open. You should go into Canvas now and you'll see hypothesis test practice 1, which means there's more. You can see all the other ones I got. Hypothesis test practice 1. You won't see any of this other stuff because I haven't published it yet. So that's just for me. Ha ha ha. But click here and you'll see, oh, look. Oh, geez. Oh, there's a second side. Oh, shit. Okay. So let me open this in a better way for me. Can you guys all find that? You might have to refresh because I just unlocked it. So it's the one about forward focus. I had a forward focus and it died so hard at the end of its little life, but it did good. It did pretty good. All right, let me look this up. Hold on. I never learned to open this before class, but too bad for everybody. All right. Oh, what would this be called? Okay. Oh, screw it, Jeff. Just download it again. Okay, Jeff. There we go. All right, hold on, guys. Here we go. Here we go. Now we got some shit here. Bam. All right, can you guys see the forward focus thing? Forward focus. All right, so I want you to just read through it and try to write the claim down. I'm going to take a very quick break. I'll be right back. Where is this guy? Oh, he's back. So who's got the claim?
I said the claim was that the population mean is less than 38.
Oh, what did you base that on?
I based it on Ford Focus came out with a 38 hours And then the sample was 37.3, which was less than 38.
When we have a hypothesis, it is before we have done anything. Did somebody else get something different for the claim? What are we trying to check? Right? So either it's a belief or it's something we're trying to test because it's a hypothesis test. What is it we're trying to check to see?
If the average assembly time is 38 hours,
Right? The same. To see if their assembly time is the same as the overall average. That is what we're trying to test. Does that make sense?
so would it be equal to then?
Good. The sample is what we do to check it. So I can't look at the sample number to set up the claim because I would have a claim before I did anything. Does that make? Never look at the sample information for the first step because it's not the step it would happen yet. All right, so the claim is it the same? That's what we're trying to test. Is it the same? So the claim is it's the same. U equals 38. Now, just to make sure you guys remember, if you look at this number, why are we going to do any work? Right? Is anybody out there going 37.3 ain't 38, Jeff? Why are we even doing shit? 5 steps. I don't need 5 steps. I can already see it's not 38. Stats boy. Is anybody else thinking that? It's fine if you are. Go ahead and tell me. Like, what the shit is this stat shit? Is it equal? No.
What's the difference between a 1 and 2 tailed test?
All right, hold on. We're getting there.
Okay.
Don't worry about that right now. Let's focus on what I'm talking about. Was our sample 38?
No.
Yeah.
So why do I do any more work if the claim is equals 38 and we got something different than 38? Why are we even doing anything? Why do we not just go to the next problem? Is anyone else thinking that way? It's okay if you are. but I
Because
want you to
there's
remember. Yes?
still the standard deviation. So you don't know if, even if the sample mean was 73, it could be 30 or 37, it could be 38.
Okay, I sort of am with you there, but there's something more fundamental than that. Where did 37.3 come from?
A sample.
A sample. Would the sample necessarily be 38 if the real mean is 38? No. So again, be real. This is what I mean. Not only does it have to be different, it has to be different enough because it's just a sample. I expect there to be some variation in samples. So doesn't it make sense that there should be, okay, this is expected, this is expected, this is, and then you get to a point where like, oh, this is where it starts to get weird, right? Okay, maybe. So if I flip a coin 1,000 times and I get 498 heads, am I freaked out? No, because I expected around 500, right? But if I get 200 heads, isn't that far away from what I expected?
Mhm.
Yeah.
Understand? That's effectively what we're doing right here. It's different, but that's just like the 498. Who cares? That's basically 500, isn't it? 37.3 might basically be 38, but this is where what somebody said earlier, the standard deviation tells me how different it really is. And it's going to show me if there's enough evidence. Okay, sorry. I just really want you guys to understand. You can't just go, well, it's less or it's not equal to or something. It's just a sample. It's got to be enough evidence. So where is this statement going to go? In the ho or the ha?
No.
Yeah, it's going to go in the ho.
What's the statement that would go in the ho?
So remember, how did we set this up? The statement that goes into the null hypothesis always has to have a what?
Alternate?
Well, how did we know this went in to the ho? How do we know?
Because, oh, it has the equal sign.
Equal sign.
Equal sign, equal sign. Why did we do that weird shit? Because I want the ha to always set up where my rejection region is. That's the only reason. We had a lot of different ways you could have set this up. We chose to do it this way. So if the claim has an equal sign, it goes into the null. If it doesn't, like the problem we did with the coyotes, it goes into the ha. Because I cannot show evidence for equal 38. But I can show evidence for the opposite of that, which is what? What's the opposite of equal 38?
Greater than or less than?
I like it. More succinctly, I could say,
Not equal to?
yes. So
Oh.
I want to say that in the past, we used to do this. But math people really don't like multiple symbols in a row, especially when there is another symbol that would be one symbol I could use. But the interesting thing here is, do you see how that tells you better that it's a two-tailed test? How can you be not equal to something? You can be greater or less. So if my sample shows up down there or up there, right? Wouldn't that be evidence that the one who thinks it isn't here is wrong? Okay, so that's why it's a two-tailed test, because it works either direction. All right, let me stop for a minute, because this stuff can drive you insane. I understand. All right. Any questions about that first step? Is that all right? Sometimes I'll have somebody tell me, I can't tell if it's a 1 or 2. It's almost always a two-tail then, because if it's a one-tail, you see something like, we think it's decreased, we think it's gone up, we think it's gone down, we think that there's less, we think that there's more. All of those words have a direction, don't they? More, less, greater, gone down, decreased, up, whatever. Here, the word is. And it's really easy to kind of like read past, and you're like, what the shit is this? Is it less? Is it greater? It's is, which is equals, right? Depends on your definition of is. That's a terrible Clinton impersonation. All right, sir. That's too far in the past for some of you young people. So now this next step, of course, now that we know what the hell we're talking about, what can we use to talk about it? What do I have to check to see if I can do something instead of nothing? That's the first thing. What tells me I can do something?
You can calculate the z-scores.
No. I sure, I can always calculate a z-score, but how does that lead to anything? What has to be true about the problem for me to know I can do something?
The population standard deviation is known.
That's not what tells me. So
Sample size is over 30.
is it normal? That's so normal? Question mark. That's the. It doesn't really matter, to be honest, which order you say these in, but it kind of makes sense. Can I do anything? That's the first thing to check. If it's not normal, you can't do shit. So then you just go to the next problem. Why is it normal? Because n equals 71 greater than 30. Central limit theorem says all good. Check. Okay. Man, sorry. I always think chicken, lettuce, tomato. Now I want a chicken sandwich. My Popeyes shut down near me. Sorry, I'll be all right. Now, how does the standard deviation come into play on the next step?
See whether you're using the z-score or the t-score.
Good. And like somebody said, we actually know the population standard deviation
Mhm.
is known. So that means I can use what?
The z-score.
Z-scores. I love it. Sure. Don't worry, there's a t-score problem coming up. What time is it? You poor guys. It's already 2:40. All right. We'll finish this problem. We'll take a break. We'll do one more problem, then we'll call it a day. Does that sound good? You're like, yeah, one more problem. That could take another hour. Yeah. All right. See if you guys can do part C. Is that too much? You know you can use z-scores now. Let me help you guys out. I would use the t-score chart for sure. Right, so I know alpha is 0.05. Right, I know it's a two-tailed test, right? Do you guys understand why you definitely want to use the t-score chart? Because it's set up for each kind of test, yeah. Let's see, maybe I should open up the t-score chart. Oh, t-scores, where the shit are you? There you are. Aha. All right, so let's look at our t-score chart. Oh man. Sorry, I'm going a little stir crazy. All right, so t-scores, we know it's a two-tailed test, and we know that alpha is, what was it? 0.05, right? Is that what it was?
Yeah.
Do you understand how nice this is? There it is, two tails, 0.05.
Where is the t-squared chart?
It's under chapter 8, because that's where we first learned about it. Unit 8. Can you see it?
Unit 8, got it.
Okay. So 0.05, two tails. Do I stop somewhere? Do we need a
At
degree?
70?
Sorry?
At 70, because the sample was 71.
Interesting. Is that correct?
I thought,
If
you
I
the way,
stop, sorry, say again?
I thought we go all the way down.
Of course we do. If I stop, I get a t-score. But did we want to use t-scores here? No, we want to use it. So we go all the way. If you stop, you get a t-score. If you go all the way to the bottom, you get a z-score. And doesn't 1.96 sound familiar? We've used it a few times. Okay. All right. If I do this, can you see you can see this again, right?
Mhm.
So this is basically like a classic problem. Do you see how it's basically setting up unusual to be about 2 steps away? Isn't 1.96 almost 2 steps away? So this is like a classic. And this is what I mean by 0.05 is the most often used one. It is the original. It is the OG. It is the OG unusual definition. 2 steps away. That's why it's 0.05 if they don't say. So if Z star, how do I get into the rejection region? Now it's in 2 places here. If Z star is, how do I get in here? If my Z star is how related to 1.96? Greater than, less than, equal to, how do I get in here? What's happening?
If it's greater than,
Yes. And what, or if my Z star is how related to negative 196?
Less than?
There you go. Then we can reject the null, support the ha. And don't forget, I mean, why does this make sense? Because isn't the ho the one that thinks it equals? So they're the ones who think it's in here somewhere. So if we get out here, if we get outside, then that's evidence that the null hypothesis is wrong. So of course the next step is, where the hell did we make it far enough away? That's the next step. Okay, we know how far away enough is. Did we make it far enough away? So let's calculate. So what do we know? What's our X bar? What's our sample mean?
37?
0.3.
Yeah.
And what's N?
71?
And what's sigma?
I don't remember. 2.25.
2.25. And then of course we have to change that.
Point 26. How many decimal places?
At least 3.
Okay, 0.267.
Cool. 267. So you guys are, so this step should feel very familiar. We've done the steps since chapter 7. Change standard deviation, make a z-score. So now the z star is going to be our data, which is the sample mean that we got, minus the supposed middle, which is 38. Divided by the new spread, which is 0.267. So Divided by.
I got negative 2.621 or 2.622.
2.62?
Yeah. If you want another decimal place, I'll just be 2.
No, we don't need it. We don't need no stinking other decimal place. Okay. You guys.
Oh yeah, because that's the new Z-score or star.
Yeah, this is our Z star. This is how far away our sample got. Did our sample get far enough away?
Yeah.
Where did it fall on the, see, this is nice. You can always do a visual, which is another reason why I call it Z star, because now I can put it there and put a little star on it. That is where our sample showed up. So did we find evidence or did we fail to find evidence?
Found evidence?
Yes, we found evidence. We can do what? We can reject what?
Uh-huh.
The hoe. Support the house. So what would happen if I got here, for example? If my sample got here, then I would say fail to reject the null. Fail to support the ha. You failed, sir. So if you're gonna fail anywhere in this class, do it on one of these problems, because that's fine then. Because that's a okay answer to get. So somebody remind me, what was the claim? Was the claim the ho or the ha?
Uh-huh.
The hoe.
It sounded like you said the who. Yeah. So that was the claim, right? Is everybody with me? Because once you start feeling better about the steps, the thing that gets people at the end is, how do I word my conclusion? But you always know exactly how to word it. The claim is the null, so I'm going to use that language. We have found sufficient evidence to reject the claim that plagiarize, right? We have found, Jiminy Jeebus, sufficient evidence to reject the claim that what? Mean assembly time at this, what was it? What did I say? Factory? Plant is the same as
Or plant?
is 38 hours. Okay. Whoa, Jeebus. All right, so let's take a break. The sooner you come back, the sooner we'll do this problem and the sooner we call it a day. So how long of a break do you want? Do you want a break? That's an option too. We could just power through this one and then call it a day. It's up to you guys. Does anyone need a break?
No.
Give me something. No?
No.
Take 5? All right, let's take a 5-minute break. That sounds good. In case somebody needs to go answer the call of nature or grab a snack, refill a drink. I got enough drink, I think. So 5-minute break, guys.
I have a question for homework 8.1, question 97.
8.1 97.
Yeah, for G.
Hold on, what was 97? There it is. For G. Oh, okay. Sorry? E?
G.
Okay. Suppose that the firm decided how the number. Oh, okay. So this is that you need to know the number of people they survey. What letter is that? What variable is that?
N.
Good. Didn't we develop? Good Lord. I'm going to die. I'm sorry. Give me a second. Didn't we create a formula to solve for N?
Yes.
It's N equals Z squared, sigma squared over E squared.
Yeah.
There you go. That's what you want to use here now. Be careful. It says 96% confidence. So you're going to need the z-score for 96%.
Yeah, for that I got 1.755. I'm just not quite sure what the E squared would be.
Careful. The z-score shouldn't be 1.755.
Okay.
I think you looked up 0.96.
Yeah, I looked at 0.96 on the Z chart.
That would find the z-score that has 96% below it. You have to find the two z-scores that have 96% between them.
Oh, okay.
Then how much is outside? If there's 96 inside, how much is out in the tails? 96%? So how much is out here? 96.
There should be 0.02 on either side.
Good. So look up 0.02.
Oh, okay.
And it'll be negative, but you don't put the negative because that's what the plus or minus is. Well, I mean, doesn't matter for this one because they're squaring it.
So would it be negative 2.055?
Yeah, sounds better. Well, just 2.05.
Okay.
Yeah. How do we know if it's two trails or tails? Okay. Sorry.
All right.
There. Oh, so, all right. So real quick, the reason that the problem we just did was two tails, for example. So let's look at the last two problems we did. I'm still sharing, aren't I? What do you guys see right now? You guys see the sheet we just did?
No.
No. See the homework.
Oh, I'm sorry. All right. That's right. I was sharing the book. Okay. So the reason why was this two tails? Because this is not equal to. To be not equal to, you could be less or greater, right? That's why it's two tails, because it's like, where could the sample show up to show it for this, up or down?
Okay, so instead that mean is equal, if say is greater or less, it's gonna
Yeah,
be
so just like
one.
this problem we did with the coyotes, it was
Oh,
greater than, so that's why it's a one tail up here, because it said greater than, so the sample would have to be above, so that's one tail.
and my other question is, we put equals because in the problem say same.
Yes,
Yeah. Okay.
the it's not like a claim like in the first one, but it's, we want to see if the assembly time is the same as, which means equals. Yeah.
Yeah.
Not is it greater, not is it less, but we want to see if it's the same.
Okay, and okay, yeah, that's good. Thank you.
Yeah.
So back to my question on 97, I'm still not quite sure what the E squared would be.
Oh, so what is it? It says for part G, right?
Yeah.
All right, so the E is the error. That's how much they think they're off by. So they want to be within how much? Does that make that within word is a very often used word and it signify error.
Mm-hmm.
They want to be within how much?
They want to be within the 96%
No.
confident.
No. Find the word within.
I gotta get the question.
So they want to be within 1 hour.
Okay.
That's how much they want to be off by. So the error equals 1.
Oh, okay. All right, thank you.
All right, I think it's time. Let's see. Everybody come back. Students come back. Sorry, you don't want me singing. I'm a teacher because I couldn't make any money singing. Well, maybe if I sang, I'd say, pay me money to make me stop. I could make a ton of money. All right. So number 2 is, sorry I gave you this problem. Because I remember in grad school, I lived a very plastic life. Can anyone relate to that? Young, dumb Jeff didn't really think ahead, and it took a while for me to pay off my credit card. But in grad school, I wasn't making a ton of money. So if I wanted to eat, credit card. Now, so the average debt, blah, blah, we believe the debt has decreased from a sample, blah, blah, blah. Okay, so kind of let everything else in the problem wash over you at first, because all you care about is the claim at first. What is the claim?
Are we supposed to see your screen?
Oh, shit. Yeah, you are. This is the other side of that. This is the other side of that sheet, sorry. So the average credit card debt, we believe the debt has decreased as other shit, but I already know what the claim is. All right, what's the claim?
That the mean is less than 906?
Good. Less than 906. Is everybody with that? And that one's a little in your face. You see the word decreased. That is a directional word. Does that make sense? Directional word? Okay. So where's that going to go?
It's gonna go under the ha,
Good, because it does not have
an equal sign.
equal sign. So what's the other old dude in the coffee shop get? What's he think?
He's the hoe.
Okay, now,
Greater than or equal to 906?
greater than or equal to 906. Now, how many tail test will this be? One tail test, which side?
To the left?
Good. Because this sets up the tail, and this is less than, it points you in the direction of where the tail will be. My sample has to show up below to show evidence that the mean is less. All right. You guys try to do the next two steps. Here, I'll sing for you while you do that. No. It is dark, and the moon is the only light we'll see. Won't be afraid. No, I won't be afraid. As long as you stand by me. So, no, I'll do some Louis Armstrong, some. And I say to myself, what a wonderful world. Oh, that's the first song I do when I go to karaoke, just to get me in the mood. Because I could do it. I could do pretty good Louis Armstrong, yes? Does that sound all right? No? Like somebody told me it sounded more like Oscar Grouch. I'm like, stop. Did somebody get part B yet? Do you know to use Z or T?
I said T.
All right, so we got one vote for T.
T
I
score.
also said T.
There's no population standard deviation.
The standard deviation that they give me came from
The sample.
the sample. That's the key. So too many people see the word standard deviation and say, oh, I know the standard deviation, so I can use Z-score. That doesn't make any sense. Which standard deviation? It came from a sample. So the first thing is, why can I do something? And the second thing is, sigma unknown, only know S. Well, what told me I could do something?
The sample size was over 30.
So that means together, that means I can use T-scores. You can't use Z-scores because I don't know the population standard deviation. This is our first one, our first T-score hypothesis test. Oh, so exciting. Let's go ahead and finish part C. We haven't done that yet. Notice I put the alpha up here, right? What's the degrees of freedom?
0.01.
Or 80?
80. The level of significance is 0.01. Degrees of freedom is sample size -1. So let's see. If I do this, can you see the T-score chart now?
Mm-hmm.
So it was a one-tail test, 0.01, right? 0.01. So I'm going to stop at 80. Is that what you guys got? 2.374? Okay. Now be careful. What's wrong if I do this? I have done something wrong. And I don't just mean I drew 2 wrong.
It should be negative.
There you go. We are the humans. We are the humans, my friends. So the T-score chart, notice, does it have any negatives on it? Does the T-score chart have any negatives on it? Does the T-score chart have any negatives? No. But there will be negatives, won't there? There will be, sometimes it's below the mean. So don't blindly take the number here. If you're putting it below the mean, you got to make it negative. Right? We know that. I really want you to understand that a T-score is basically a Z-score, just a little bit bigger. So it still is negative if it's below the mean. It has to be. Okay. All right, let me see. So I got to make that negative. So if, now here's where I want you to, oh boy. I'm using T-scores, right? So if my T star is less than negative 2.374, then we can reject the null, which is why it's called the rejection region, which means I can support the other guy. If I get in there.
I have a question.
Yes.
So I got 2.639.
Oh, sorry, I saw that. I was trying to remember what it was. 2 point what now?
2.639.
639.
So in the one
Over here. All right, so help me out. How many tail tests is this?
1.
1. If you look at one tail 0.01.
Oh, okay. I was looking over there. Yeah.
That's
Okay.
fine. That's fine. Don't worry. You helped out several people out there right now. So that's why it's so important to know if it's a 1 or 2 tail test, because it tells you where to find your alpha, which row. So it's going to be up here. Then you get your 2, 3, 7, 4. Okay, I like it. How's everybody else? Is anyone concerned what the formula is for the T star? You guys are like, whatever, dude, man, just show it to me. It's the same formula. Formula doesn't change. It's the same formula. Isn't that nice? It's the exact same formula as Z star. It's the same formula, so do not freak out. So let's see, what do we know from this? What's X bar?
$880.34.
880.34. What's N? N was 81. What's S?
$106.25.
Yeah, 106.25. Is everybody cool? 106.25. And here's the step that freaks people out still, even though I explained this before. You still have to do this, of course. So when you do this, you're not making a sample standard. No, stop. You are making the standard deviation for groups. This is the one for individuals. I still have to make the one for groups, because don't we have a group of 81? Oh shit, I better make the right spread. So I got to take the old one divided by 9. 10. So it's like 10.6.
11.805.
What's wrong with me? 1. Oh, I see what I did. I'm silly. All right, so I got pretty close. Still. 11 point who?
806.
806. Does that sound good? Okay. And then you just take a deep breath and remind yourself that T's and Z's are fundamentally the same thing. They have the same formula. Thank God. So it's going to be our data, 880.34, minus what? So that's our data, right? 880.34 minus what?
206 or 906.
906. I love it. We're assuming that's the mean. We're assuming that's the middle, and then we're going to go see if we do something weird with our sample. So minus 906 divided by the new spread. Let's see if Jeff made a different problem. Let me see. You trust yourself still, Jeff? I do. Divided by 12. It's going to be like, I don't know, 2 point something. My brain's hurting.
Negative 2.173.
Oh, yay.
74.
7, it doesn't matter. 7. Okay. Is that what anybody else got that same thing? You guys okay out there? You're all like, can we hurry this up, Jeff? You said we could leave, and so I want this done now, so I can turn the Zoom off and go do whatever the shit I want to. All right, just give me a minute. So what does that mean? That we got this. What does that mean? What do I do with it now? What do I do with that? It's a number.
It doesn't fit into the rejection region.
Yeah, where'd it go? Here's 0, right? So where's 217? It would be right there. It didn't quite make it, did we? We failed. We failed, which is fine. Failure in this problem does not mean you did it wrong. It's a possible outcome. We failed to do what?
Reject hoe.
Good. We are terrible. We failed to reject the hoe, and we failed to support the high. That's right. All right. Because we didn't make it far enough away to reject the null, so of course we failed to reject it. All right. So, which one was the claim? The ha. I like it. So there, I'm going to use, I'm sorry, I put high there. I'm going to use this language, right? So we're going to get that step. Everybody's always like, do I say reject or support in the freaking conclusion? That's all you got to do. Which one was the claim? Use that language. So failed. We have not found sufficient evidence. Good Lord. 2, support the claim that. Plagiarize. The debt for all students in college has decreased. Oh my God, this approximates English. This is my own alphabet that I use. I've created my own language. So I'm sorry for you guys. Nobody feels 100% comfortable. Do you guys feel a little bit better about what goes into this? Don't forget this. Section 9.5 is the first place in chapter 9 that you have complete hypothesis tests to do. Every section before that kind of focuses on one piece or another. There is a section that talks about types of error. I will let you read about that, and then you can ask me questions tomorrow. Any questions about this? This is really early and I don't care. Is anybody upset that I'm not giving you your money's worth? I think one time I had a student actually complain about that. I had somebody, he lets us out early too much. And I paid money. I'm like, oh my God.
Can I ask you another question about
Yes.
chapter 7? Now that we're done with this.
All right, hold on. Just is everybody cool with this? Everybody feel you got all this stuff? Okay. All right. So you guys can hang out near Billy's question, ask your own question, or you can head out and get started on that quiz. What's your question, Billy?
Hold on. I'm gotta cycle through. We just went through a bunch of information, so I gotta go backwards. How is it possible for the standard deviation to be greater than the average?
Yeah, we actually talked about that, or it was a bonus question I gave on something. I can't remember. So the easiest way to think about that, is to have some negative and some positive values. Right, so like, if I had -1, 0, 1, what's the average? What's the average of -1, 0, and 1?
0.
0. Is the standard deviation 0?
No.
No, it's bigger than 0. There you go. There's a standard deviation bigger than the mean. That's the easiest way to have a standard deviation bigger than the mean, is to have some negatives and some positives. The other way to have a standard deviation bigger than the mean is to just have really, really wide spots between your data points. So if your data points were 1, 500, 28 million, I mean, the 1 and the 500 are going to drag the mean down, but the huge spaces between the numbers are going to make the standard deviation bigger. So if you just have really big space between each data point, really spread out, then standard deviation has a chance to be bigger than the mean. Does that make sense?
Mm-hmm.
Because that's what happened on this problem. The standard deviation was way bigger than the mean. And it kind of makes sense if you're talking about income in countries. Aren't they going to be insanely spread apart? Aren't you going to have some countries that are going to just be, everybody's making a ton of money? Like America, for example. Americans have no idea, right? Being poor in America is like being rich in a different country. So the disparity, the difference is so huge that it actually ends up being 4 times as big. The spread is 4 times as big as the average.
Okay, and then the last question is E, why is it more likely that the average of 1,000 residents will be from 2,000 to 2,100 than from 2,100 to 2,200? And is it because it's wedge shaped?
No, it's not wedge shaped. We talked about this earlier. The original population is wedge shaped, but then didn't we take samples?
Oh, yeah.
And that became normal if I plot it all. So why are the averages? What's the mean again?
2,000.
2,000. So shouldn't, in a normal curve, where would most of the data be? Considering what the shape is, and the mean is right in the middle.
Around the mean.
Around the mean. So which one of these ranges is closer to the mean?
2,000 to 2,100.
So there should be more data in here, meaning that the probability would be higher. That's why as you get closer to the mean, that it gets taller, meaning the probabilities go up. Does that make sense?
Yeah, it does.
So it's the whole idea, it's a lot less likely to pick 20 people with an average height of 7 feet than it would be to pick one person with a height of 7 feet. It's a lot less likely to get 20 people. Holy shit.
Okay. I'm going to do the rest of the homework and then try to tackle this quiz.
Okay.
Say a prayer for me.
Ready, whatever deity you want.
Okay.
Coffee,
Please, Jimi Hendrix.
flying spaghetti monster. Oh yeah, Jimi Hendrix can be your god, of course.
All right, hey, I really appreciate you, man.
Sure.
And I'll see you tomorrow. I'm sorry I missed yesterday, but I have to pay my car note, so I had to.
Video's up. So if you want to take a look,
I will. All right, thank you, sir.
sure. Everybody else okay? I'm gonna take that as a yes, and I'm gonna head out. Bye, people.
Bye.